We are here at the seventh symposium of International Symposium on Energy and Protein Metabolism and Nutrition with Dr. Walter Gerrits. He is a professor and the head of the animal production group at Wageningen University in the Netherlands. Dr. Gerrits, you will be conducting a calorimetry course in this event after the finish the program, and I would like to know more about what are you going to discuss in this course, and what are the main applications of those systems with calorimetry.
All right, thank you. And indirect calorimetry is a way to measure heat production by the measurement of the consumption of oxygen and the production of carbon dioxide. It's one of the standardized methods that is used by a lot of people attending this conference to measure energy balance of animals. This has been traditionally used quite a lot to measure the energy values of feed ingredients, but increasingly people use this kind of techniques to measure the effects of different environmental conditions, interactions between the immune system and nutrition. So it's a technique that you can use to measure the production of heat. And at the same time, a lot of people measure also the nitrogen balance, so you get actually an estimate of protein deposition and fat deposition over a wide range of animals. Now, it's kind of a technique that requires a bit of expertise to conduct. That's why we have been, since I think 2013, we started this course in conjunction with the ICEP conference in Davis, and every 3 years we do it, and it's intended for technicians and for PhD students, but also for other people who would like to use this kind of technique in their research.
Excellent. Within direct calorimetry, you can also measure probably the impact of the behaviors of the animal, if they are in movement or if they are lying, or what are the main aspects? How can you quantify locomotion? Is that possible to add that to a model that calculates the maintenance requirements?
There's a lot of questions in one, but yes, you can measure locomotion, you can quantify locomotion, and therefore you can also separate the heat production that is related to physical activity and that is unrelated to physical activity. The problem is that most respiration chambers are too small for animals to be moving around freely, but there are facilities available in which you can have group-housed pigs or group-housed chickens or even free-ranging cows. If you have a surface of, let's say, 6x3, you can have 2 or 3 cows in there, but that's the maximum space that you have available. If you want to measure heat production during grazing conditions, for example, or out in the field, you need to have, let's say, estimates that are calibrated in these kind of calorimeters. So you can do that too, but the measurements in respiration chambers are with limited movements.
Okay. So one of the ideas of nutrition is how we apply this information to make more precise feeding systems. So what will be the steps to take this information from indirect calorimetry to take it to, let's say, feed formulation and feeding practices?
Okay. Yeah, that's a very nice question. I think you should not forget that the net energy systems that are used in many countries these days are all based on indirect calorimetry measurements. So the data sets from Rostock in Germany back in the previous century, but also at INRA and at Wageningen University and at different places, people have been estimating the heat production in response to different ingredients and thereby making net energy values for individual ingredients. So that's used today. Now, the way forward, I think, is also to quantify interactions between the environment and nutrition. For example, we do measurements on animals that are housed under low sanitary conditions. We see a higher rate of heat production, a lower nitrogen retention. you can use this type of information in feeding systems. But it is an interaction between the nutrition and the environment. So it's difficult to attribute that to a feeding value in a feeding table, but it is more on the requirement side.
On the requirement, perfect. And also, in this meeting, you are presenting this paper about validating the oxygen pulse heart rate method. Could you tell us a little bit about, I think that you did it with dairy cows, and what will be the applications of this system?
Yes, this is a study that we did together with people in Uruguay. And there's a lot of grazing in Uruguay, and what they do is they measure the heart rate of cows, and during a short period of time they measure also oxygen consumption. So they have a mobile device that they use to measure for individual cows the oxygen consumption and the heart rate. If that is quantified, they chase the cow in the paddock with the heart rate measurement, and they calculate heat production from heart rate. What we did in this study is we suspected that heat stress would have an effect on the oxygen pulse. So we did a study in which we varied temperature, relative humidity, and airspeed, and we checked to what extent the oxygen pulse was constant. We would expect that if temperature goes up, because cows can be sweating a lot, that the function of the heart changes. It's not only for transport of oxygen and carbon dioxide, but it's also for transporting moisture to peripheral tissues. So we checked whether that was constant or not, and we found out actually that there's a huge difference between individual cows, but the effective temperature is very small. So you can use this technique out in the field. So we use the calorimeters for calibrating and designing these kind of equations. You can use it in the field by simply measuring the heart rate of individual cows. With the only difference is that you do have to measure oxygen consumption during a short time. So you need a mobile device to do that.
Perfect. And this helps also to improve the accuracy of the model to predict the requirements of a cow when it's under grazing conditions, or what other benefits it may have to advance more in the individual nutrition of those cows.
Yeah, I think it does. It does help, and there is a lot of literature out there. But these people that we collaborate with in Uruguay, the cows are moving quite a lot. Sometimes they have to walk a lot before being milked, and that bears an impact on the energy that they need to consume. And there is individual variation as well. This morning we heard also a presentation on the effect of physical exercise in pigs. So it has applications also in the precision feeding of pigs, with the introduction of a lot of sensors in which we can record for pigs, for cows, individual movements. You can explain variation between pigs, but maybe if you can precision feed your animals, you can also take that into account on the requirement side.
Excellent. Thank you, Dr. Walter, and I hope that we can have you in a future podcast and webinar. And thanks for your course, and I hope that in the future more people can attend it. It's an excellent meeting, and you are one of the leaders of this event. Thanks a lot.
My pleasure.
Thank
Thank you
you
very much.